Okay. Hi, I'm Greg. I release stable kernels. I also maintain different parts of the kernel. I maintain a USB subsystem, the TTY, serial ports. People still use serial ports. It's crazy. My first job ever out of college, I was working on a serial port on a UART. That was 25 years ago. I'm still doing serial ports. Staging part of the kernel, really crappy drivers, and a few other places. So I do a lot of kernel work. I work for Linux Foundation. So let's talk about the kernel. This is the size of it. As of the 4.5 release, which was almost 2 months ago, Linus thankfully didn't make me do all my numbers again because he didn't release a new kernel last night. He's going to do it on Sunday. So it's the size, 21 million lines of code. It's huge, huge number of code. You don't run all this stuff. All the drivers for all the hardware and all the architectures is in the kernel tree, all together. My laptop runs about 1.6 million lines of code. Your phone runs about 2.5 million lines of code. Your phone runs more. That's about it. So everybody runs the core of the kernel. The core of the kernel is 5% of that. Networking is about 35%. Drivers, all of them, about 40%. There's about a bunch of stuff. So it's the size. It's a huge, huge project. But what's more interesting is how many people work on this. Last year, almost 4,000 different developers. At least 440 companies. I say at least. I haven't done my numbers. I keep track of who works for what company. I haven't updated that. So it's the largest software development project ever in the history of computing. By the number of people using it, or developing it, and now using it, and the number of companies involved. It's a huge number of people. The fun thing about that number is half those developers only contributed one change. Half to half contributed two, half to half three. It's an exponential curve. But our curve is better. About a decade ago, the top 20 people did 80% of the work. Now, the top 250 people do 60% of the work. So it's gotten a lot better. Our number of people who are contributing in large ways is growing, which is really, really good. And it shows a vibrant community. A lot of stuff. So this is our rate of change. I've also localized all the numbers. That's 10,000 lines added. It's not that bad. You know, normal size project until you realize the units. Is this recorded? All right, so the Linux Foundation told me to stop using the word scary. You guys can count, I'm going to say scary a lot. The traditional computer science model is everything, once you get it working, you tested it, it's verified, you don't touch it. It doesn't change. Linux runs the world. We're modifying Linux really, really fast. Now, you might think, oh, all the drivers are changing. That's fine. All this other stuff is changing. That doesn't bother me. No, but everything is changing. Every single day. It comes down to this. Almost 8 changes an hour, 24 hours a day, 7 days a week. And those changes are equal across the whole tree. So I said the core of the kernel is 5%. 5% of the changes touch the core of the kernel, the thing that we all rely on. 50% of the changes are drivers. It's flat. It's been flat for a decade. Over a decade. I think I've been tracking these numbers for a long time. And this number is huge. Every single year I say, we're going just too fast. We can never go faster. And every year I'm wrong. When I first started doing this, we were doing 2.5 changes an hour. And everybody's like, no way. We can never go faster. That's insane. Microsoft and Apple said, you guys win. Literally, they said that. We cannot keep 8. You guys are going to go faster than anybody. There's no way we can keep up. We are going faster. And we keep going faster. Every single time. 4.3. We did 8.1. The next release that comes out, I think we cracked 8.5 changes an hour. We did one of the largest kernel releases ever. This is scary. If you rely on this stuff, right? Nobody relies on this. Now, we make a lot of changes. And we're not just making changes because we like to, because that's more work, we're really lazy. We're making changes because we have to. We're making changes because the world changes. The model of you make a box and you make it static and you throw it in the corner doesn't work because that box has to talk to the world. And the world changes. Everything interacts, so you have to evolve. If your operating system does not change, it is dead. It's that simple. If your device does not change based on the world that it interacts with, it is dead. And it's that simple. So look at operating systems that don't change. Nobody uses them anymore. There's a bank in Japan, that's it. It's just that's the way it works. I make fun of Japan, I'll make fun of Japan later. I just was there. They use Linux crazy. We're going fast. So we're making a lot of changes. Now everybody's scared. So what do we do? How do we do this? We do two things. We rely on time-based releases and rely on incremental changes. I'll talk about incremental changes real quick. We don't take a big, here we'll rewrite the scheduler. Here we'll redo this. We will take a new driver, but we want to see your work evolve. It's like your math professor says, show your work. So we make you break up the changes and do extra work in order to prove that it's something that works. So if you want to make a change, you have to break it up into little tiny steps, send all the little steps, explain them all, and then we'll say, oh, that looks good, this doesn't look good, and we'll accept them and not accept them. And we waste engineers' time because we have a lot of them. What we don't have a lot of is maintainers. We don't have a lot of people reviewing. We have about, 4,000 developers. We have 700 people who maintain a portion of the kernel. We have really 100 people that maintain and do all the review. Very few if you look at the ratios. So we need to maintain, we need to keep the maintainers happy and sane. You want to make it easy and make it obvious. If I don't accept your patch because it's obviously correct, I'm the foolish one. So you need to make it simple, and that's what we do. We rely on that, breaking down your changes into individual stuff. And that works out really, really well. The other thing we do is time-based releases. And time-based releases we've been doing for about 12, 15 years now, and it works out really good. Originally we said, let's do every 2-3 months we'll do a release, and Linus is regular. We said, this has happened. After the past 15 years, we've done a release every 2.5 months. It's extremely regular. And the good thing about this is, if you have some big changes you want to get done or anything, and it doesn't get in because we push back, it's like, you should change this stuff. You know the next release is going to come around. It isn't like 6 months. It isn't a year that you have to wait. So we'll say, we'll squeeze it in now and fix stuff later. No, it's good. It's regular. 2.5 months, everybody can wait that. You'll wait and you'll get into the next release. And that's also very good for planning. People can plan when they need to do a release based on their hardware coming out, when they're going to get their stuff in the kernel. It's very predictable. We are very predictable and we're very stable that way. Every single release, also, we don't break things. We make the guarantee to the world that we will not break user space APIs that you notice. On purpose. The only time Linus gets pissed at people is if I break an API on purpose. If I break an API and I don't mean to, hey great, we'll fix it up. But you don't break an API on purpose. We sometimes break an API on purpose because we want to see if anybody's using it, because we don't always get it right. I mean, we're not copying everything anymore. About 10 years ago, we implemented Unix, great, now what? Well, we have to lead. We have to create these brand new things, and we get it wrong. And we have to evolve and figure out how to do things over time. Look at C groups. Look at all the nightmare C groups and how that's had to evolve into a way that's sane. It's taken a lot of work and energy and effort because we got the first try wrong. It's hard. It's a hard thing to do. But we do it. And we break it down, but we rely on this, and we make that guarantee we're not going to break user space. So that you, as a user, should feel comfortable with taking a new kernel every 2.5 months, because we're not going to break anything. The kernel developers made that guarantee about 12 years ago. Nobody believed us. And then we did it. We've done it since then. Facebook did a test. They've been running a new kernel on their infrastructure for the past 4 years. Nothing broke. Every single new kernel, nothing broke. It just works. We're really good at this. Trust us. Anyway. So that's why that's scary. That's good. So let's see how we do a release. So let's talk about it. So numbers are just numbers. They don't mean anything. They get big and we get tired of them, so we usually pick another number. 4.2, Linus does the release. And then all the maintainers throw crap at him for 2 weeks that have been tested. And then Linus does a release, RC1. After RC1, it's bug fixes only. So then, another week later, release candidate 2, 3, 4, 5, 6, 7. Sometimes we'll do 7, sometimes we'll do 8. Linus released RC7 yesterday. We'll do another one. He'll do a real release next week. This looks good. But it's bug fixes only for the majority of the 2.5 months. We test it. We have tons of good testing tools. We have good static analysis tools that happens even before stuff gets to Linus. And we beat and beat and beat on this stuff. And then Linus does a release and goes off and do another one. That's the cycle we do every 2.5 months. And we started doing this about 15 years ago, and we realized, wait, what happens about bugs about people running 4.2? We don't want to make them run our development stuff. How do we do this? So we came up with the idea of stable kernels. And here's what the stable kernels do. So I'll fork off 4.2, and I'll do a new release, 4.2.1, 2.3, 4.5. And I do these releases. The rule is, it has to be a bug fix, it has to be obviously correct, or a new device ID, and it has to be in Linus's tree. So it has to be in Linus's tree before I will take it in the stable tree. And that ensures that the people running and relying on our stable trees, if they jump to the new one, it doesn't break. Nothing happens different. So that's the rules. And that's worked out really, really well. I do a release about once a week. And in that, about every release, it's about 150 patches per week of stable fixes. It's a lot. It's a lot of stuff changing, a lot of stuff being fixed. That's what we do. Stable kernels. And the nice thing with 4.6, when 4.3 comes out, I throw away. I say, 4.2, I don't want that anymore, and move on because we guarantee that you can continue on and everybody's happy. Well, I used to work for Novell in SUSE. I ran the kernel team there, and the enterprise, I use quotes, model is one stable kernel. We never update it. It just continues on for forever. I think Red Hat and SUSE now support some kernels for 15 years, which is crazy. Not as crazy as Japan. Japan is changing their whole social infrastructure, all their stoplights, all their trains, all their stuff. They're using Linux. And they came to me and said, we want you to support a version of Linux for 30 years. I'm like, hey, I can retire. But they know what they're doing. They want to maintain a kernel, a specific set of hardware within a specific set of boundary, but they can update that kernel. They're relying on the fact that they know they can update that kernel, and that's real important. We'll talk about in a minute. So Japan is crazy, but they're crazy in a good way. So we throw it away and we keep on going. So long-term kernels. So I started doing long-term kernels. My day job made it easier, and then the community started relying on it, and companies. So we made a rule. I'll pick one kernel every year, and I'll maintain it for 2 years. After 2 years, the number of fixes kind of drops off a little bit, but I did the numbers. So I maintained 3.14 and 4.4. Sasha from Oracle is maintaining 4.1, and there's a few other kernels being maintained by different people who work for different distros. Yuji is maintaining it for SUSE. I think he's maintaining 3.6 or 8, I'm not sure which. But the interesting one is Ben from Debian kernel maintainer. He's maintaining the 3.2 kernel. He's been maintaining it for 5 years. He said he's going to be doing it for another 4 or something crazy. Debian does a lot of long-term stuff. But if you look, in those kernels that Debian's been maintaining, they're getting about 2 changes a day to that kernel. They're taking the fixes and they're merging them in, and that's good. So they're taking that rate of change, and they're still applying it to the old stuff, which is really good. And that's nice to see. Debian does a really good job of this. Red Hat and SUSE, Pardon me? 2638, yeah. Let's not talk about that bastardized kernel. I used to work for these. It came from that model, so I can make fun of them. Red Hat does do a pretty good job of stuff. SUSE does a good job. SUSE's model's changing. They got Tumbleweed, which rolls forward, which is nice to see. It'd be nice if enterprise people do it, start relying on the more secure stuff. So let's talk about security, since this seems to be a theme here. So we're doing a lot of rate of change. We're changing a lot of things. How do we keep things secure? So the traditional model of the kernel security team is you tell us a bug, and we'll fix it. Because all bugs might be a security issue. We don't know if it's a security issue or not sometimes, and it's at the lowest level. Sometimes we can give a denial of service to your machine, we get a local root user, we can, at the worst case, crash a machine remotely, or even much worse, we can get in remotely. It has happened. We want to make sure that those things don't happen. Kernel bugs are serious things. We want to fix these things. So our goal is, and the rule has been for the past 15 years, is we fix it as soon as possible. You let us know about it, we will fix it. And we get it out, and we push it out to people. The problem is, nobody takes it. I fixed a bug in the T2Y, I didn't fix it. Somebody fixed a bug in the T2Y layer about a year or so ago. No, sorry, 3 years ago. And it looked like a normal bug, fixed it, merged it, pushed it in their stable releases, and got it out there. And then 3 years later, somebody realized it was a security hole. And you could get a local root user, and away you could go. Turns out Red Hat and SUSE had to go back and fix all their old stuff. We have a very bad history of keeping bugs alive for a long period of time. Somebody did a check of it. Most bugs live for 5 years. Known bugs live in 5 years in systems. So these are things that people know. People know how to exploit, and they're not closed. That's a problem with our infrastructure. That's a problem with the business model of the companies providing the support. Hey, I work for a nonprofit. That's funded by those companies, which this is not recorded. So you have to get things updated. We have to update things soon and quickly. And I'm averaging 10 fixes a day. 10 fixes a day of things that might be a security bug or might not, because I don't have time to keep up and try and test and see whether those all are or not, but other people do. There are agencies and other companies and other organizations out there looking at everything we fix and seeing if it can be exploited and taking advantage of it. So we pushed it out to you, we fixed it, that's the best I can do, you better take advantage of it. And you're not. And that makes sad, because we're doing the best we can. We're fixing them and we're getting them out there. So this is what I now have to say. Your machine's insecure, unless you're running my kernel. Or based on my kernel. Or based on another one. If you're not taking these fixes, it is insecure. So some companies have been taking the long-term kernels and basing a product off of it. My phone is based off a long-term kernel. Shipped an Android phone based on a 3.10 kernel. There's been a fix in the 3.10 stable kernel tree for about, 6-8 months now that allows me to get root on my phone. It is not fixed. That you can base your kernel and base your product on a long-term kernel, but if you don't take advantage of it, it means nothing. You have to be able to update your machine. You have to be able to provide a system that your machines are updated and you constantly take advantage of. If you think you're going to look at these stream of patches and pick or choose, good luck. I would love it if you did. Big organizations are not doing that. Again, scary stuff. This is scary. You got to take advantage of it. Take advantage of the work we're doing. 10 fixes an hour, or 10 fixes a day. So after 2 years of the 3.14 kernel, 1/3 of those fixes are going into there, so they apply. So that's about 3 to 4 patches a day are getting into there. Again, the 3.2 kernel, 3 or 4 years old, 4 or 5 years old now, is getting 2 fixes a day and updated. Ben's doing a release every other week. It's getting into Debian. Debian's doing an awesome job. So a non-profit organization built of volunteer people is doing a better job than some of the largest Linux providers out there. That's a shame. That's bad. Base yourself on Debian. Or update your kernel all the time. CoreOS does a great job. I like CoreOS. Other systems are doing that. SUSE Leap does that as well. Arch, Fedora, people based on community distros take advantage of the work the kernel community does. They don't think they're smarter than them, and they push their stuff out there, and it does a really, really good job. Embedded devices that can be updated remotely and quickly, like the Chromebooks. Chromebooks are awesome. They update their patches all the time. You get a new release. It takes a good security model of knowing how you can boot differently, different partitions, and it works really, really well. Very good job. Google's done an awesome job with that. Very secure, very good idea. So, fix things as fast as possible, push them out, and hope the world uses them. Not a good model. So, Matthew Garrett, who works for CoreOS, somewhere in the room, about a year ago said, this model we have is not sustainable. We got to do something about it. Constantine is the kernel.org. He's our Linux kernel sysadmin. He runs our infrastructure. He works for the Linux Foundation, in charge of the Linux Foundation's infrastructure. And he also does work for Fedora, working on their infrastructure, I think, as well. He's an awesome, awesome sysadmin. He knows his stuff. He gave a talk at the Kernel Security Summit about middle of last year and compared the current industry of computing to the automotive industry of the 1960s. Those engineers can make really big, fast cars that go really well, and then they kill the people inside. We need airbags. The computing industry needs something. Go read those slides. The slides are really good. It's a nice presentation. We need a way to protect ourselves, to protect our users, because we're not doing a good job. The fact that we need to constantly update might not be always the best thing to do. We need to change this. So Case Cook works for Google, one of the kernel security maintainers, came to the kernel summit last year and said, we need to stop this. We need to change this. A lot of the problems that are out there have been solved. GRSec is this huge monolithic mess of a patch that does provide security of ways that if an exploit happens, it keeps the exploit from getting anywhere. SE Linux, everybody needs to use SE Linux because there's protection there. We have these airbags, and we need to start using them better. We need to stop exploits from happening. We need to reduce the whole swatch. And this research has been done. Nobody's taken the time and effort to actually put it into Linux. We need to do that work. And all the kernel developers said, you're right. We need to do this. And we need to do it now. So we're changing our mindset and we're changing this. Because a lot of these things that the security industry has come up with, or researchers, are a pain in the ass for a kernel developer. One of them hides kernel pointers. So if I'm doing debugging, I can't see what's really going on. Well, if a kernel pointer actually exposes information to user space, so bad people can do things with that too. I need to take the hit as a kernel developer because I have more users than I have kernel developers. And I need to make this stuff. So we're doing that. We're changing. So we've come up, and it's happening already. So it's been about not even 6 months since then. And now we have kernel hardening project. What it's doing is it's taking bits and pieces from GRSec, OpenWall, and there's one other group too. A bunch of stuff out there. There's a lot of code out there, and they're feeding it into the kernel. They're taking these patches and they're doing the work. The Core Infrastructure Initiative is run by the Linux Foundation. A whole bunch of companies came together and said we need a way to ensure that the internet is secure. This happened up at Heartbleed when everybody realized nobody's actually getting paid to work on OpenSSL. But Core Infrastructure Initiative has a bunch of money, and they're using it to fund OpenSSL, OpenSSH, OpenBSD, some kernel projects, and a bunch of other crypto things, and they're funding a lot of good stuff. They are willing and able to fund developers to do this work. It turns out it's hard to find people to hire because everybody's been hired. Everybody has these skills, already works for somebody, so luckily Google and Intel and Red Hat and SUSE have donated a bunch of developers, and they're feeding these changes into the kernel. These changes are in there, and they're coming new. But these are new features. So like the new kernel that comes out next week has a new way, finally we turned off the ability to write to static data. So you can't overwrite things. So an exploit that goes out and scribbles over some variables or a function pointer and then jumps to something else is impossible. It can't happen anymore. That's coming in the new release, but that's a feature. So people don't backport that to old kernels because that's more extra work and it doesn't happen. So unless you're constantly updating, you're not getting these new features that we can ensure that we're protecting you better. So you need to keep updating for those new features because we're doing that for your protection. The kernel before that, we added some other big good stuff, and I forgot them all. I'll blame jet lag. But we need to do that. We need to upgrade to new secure things so that these exploits that come out, because we can't fix them all the time, and with these bugs that do show up will not hurt you. And that's happening today. So these are really good things. We want help. There's a whole big long list of projects there. If you, as a developer, want to work, we will fund you. It's that simple. I think about out of the 4 people we wanted to fund, 2 of them said, nah, we'll do it on our own. The other 2 people said, sure, we'll take the money. Which is kind of funny. But anyway, it's a good group, it's a great project, and it's picking and teasing the good pieces out and making it better. GRSec is a really interesting thing. It's a monolithic, crazy patch set that nobody can dig the pieces out of. As we tease the patches out and go through the kernel review process, we're finding bugs. We're fixing them and we're making things faster. If you look at some of the features that are going in the next kernel, it will be 4.7, for some of the stuff for poisoning slabs and things like that, we actually sped things up by the fact they got introduced by fixed bugs. So keeping monolithic patches outside the kernel tree is a bad business model for the kernel community. It's a good business model for your company, but it's a bad business model for the kernel community. So don't do that. So this is what you need to remember. This was published in 1911 by an astronomer who realized that nature constantly changes. Constant change is happening, so you have to keep up. But I can't stress this enough. If you aren't changing, then you're dead. Or you're sitting in the corner and you're not talking to nature. You're not interacting. You have to change, you have to keep up, and you have to keep going. That's why the kernel changes so much, and that's why you need to keep on top of that, and you need to keep doing that if you want to survive. Thank you very much.